Okay, so now let's go and to example number 4, and we're going to be using the discriminant. So a couple of things that we're going to do in this example. So first of all, we're going to find the discriminant, and then we're going to use the discriminant to predict the number and the type of solutions for each equation. Okay, so we're going to be able to say how many solutions we're going to have and what type of solution based off of the chart that that I showed you in the last video. And afterwards, you're going to tell whether the equation can be solved using the factoring or whether you should use the quadratic formula. Okay, so it's kind of a lot of things there to do, but it all stems from knowing what the discriminant is. All right, so first of all, the discriminant is b squared minus 4ac. All right, and we know that our a is 10, our b is -1, right? Because what number is in front of x? There's a little ghostly -1 right here. Arr. And our c is -2. So let's go ahead and rewrite this in parentheses. So b squared minus 4ac. And now let's plug in our values. So our b is -1. Our a is 10. And our value for c is -2. Okay? So -1 squared is 1. 4 times 10 is 40, times 2 is 80. And now let's go ahead and deal with the sign. A negative times a positive is a negative, and this negative times a negative is a positive. So we get 81. Okay, so we want to look at a few things here. Okay, so since the discriminant has a few characteristics. First of all, our discriminant was positive, right? Okay, so it's positive, and the second characteristic is that it's a perfect square. Okay, it's a perfect square. All right, so according to our chart, and I'll turn back to it here real quick. According to our chart, if it's positive and if it has a perfect square, then that means it's going to have 2 rational solutions. Okay, so that means that it says use the discriminant to predict the number and the type of solution. So that means we can say that it's going to have, so we're going to have 2 rational solutions. Okay, and it says tell whether the equation can be solved by factoring or whether the equation or whether the quadratic formula should be used. Okay, so remember how we talked about we're going to use the quadratic formula or completing the square if this is not a perfect square. And let me just go back to that statement again. I wrote it down way down over here. I said if the discriminant is a perfect square, including 0, because 0 is a perfect square too, right? 0 times 0, then you would use the factoring method. But if the discriminant is not a perfect square, then you would use the quadratic formula or completing the square. Okay, so based off of that information, since 81 is a perfect square, we're going to use the factoring method. Okay, it would be a lot faster to solve this guy by using factoring, because you can factor probably a lot quicker than you can by using the quadratic formula. So we're going to use the factoring method. Okay, cool. So the discriminant tells us 3 things. Let me just review those things. It tells us the number of solutions. It tells us the type of solutions. And it tells us what kind of method we should use. That's pretty cool right there. Again, like, it doesn't tell us what the solutions are. It just gives us some characteristics about the solutions. Okay, so since the discriminant was 81, that meant we're going to have 2 solutions. They're going to be rational solutions, which means they can be written as a fraction. And we would use the factoring method to solve that. And it doesn't mean that you have to use the factoring method. It just means that would be the most efficient, and it would probably be the fastest. But you could use the quadratic formula. You can use the completing the square. You would still get the same answer, but it may just take a little longer. Okay, let's now do example B. So let's go ahead and do the same thing. Let's write out the discriminant. Our A, let's see right here, is going to be 3. Our B is going to be -1. Oh, but look at this though. Notice that this is not written in the standard form. I should probably make a note of that. When we do the discriminant, it has to be written in standard form. So we actually need to move this little puppy over here. So I'm going to subtract 7 from both sides, which means that my equation is actually 3x squared minus x minus 7 equals 0. Okay, so very important there. Put in standard form first. So that means my C value is not 7, but it's going to be -7. Oh, there we go. All right, so let's go ahead and plug it into the discriminant. That's b squared minus 4 times a times c. And let's go ahead and plug in what we know. We know that this is our b, which is -1. We know this is our a, which is 3. We know this is our c, which is -7. And let's see, make sure that's right. That's b squared minus 4 times a times c. Okay, so this is 1. 4 times 3 is 12. Times 7 is 84. But now let's see, a negative times a positive is a negative. And then a negative times a positive, or I'm sorry, times a negative is a positive there. So we get 85. Okay, so that means it's positive. So I know we're going to have 2 solutions, but wait a minute, is this a perfect square? Not can our perfect square go into it, is this one of our perfect squares? Like, is it 4, 9, 16, 25, 36, 489, 64? It's not, right? So that's why we would say we're going to have 2 irrational solutions. Oh, you a tricker me. So yes, we have 2 solutions, but they're going to be irrational because this is not a perfect square. Okay, so that's the first thing we can say. Well, actually, that's 2 things. We have 2 solutions, and they're going to be irrational. And the third thing we can say is since this was not a perfect square, we're going to use the quadratic formula. Okay, we're going to use the quadratic formula to solve this. Okay, and let's do one more example here. Example C. Oh, and go back a little bit. Okay, so let's first write this in standard form. So I'm going to move this 40 over here. So subtract 40, subtract 40. So we get 16x squared plus, wait a minute, I think I'm missing an x here. Let me just look at my little example that it was supposed to be. And, oh yeah, that's supposed to be a 40x. So this is supposed to be a 40x here. So I'm going to go like this. Okay, so we have to put everything on the left side. All right, so we get 16x squared. Now, notice that it goes x squared, then the x term. So I'm going to do minus 40x next, and then plus 25 equals 0. Okay, because I want to stay consistent with this. Okay, like I want it to be my ax squared, my bx, and then my c. ax plus bx plus c. Okay, so move it all over there. Now go ahead and let's write this in the discriminant. So that means my a is 16, right? My a right here. And my b is -40. And my c is 25. Let's plug it in, plug it in. b squared minus 4 times a times c. Plug in this dude. My b right here is -40. My a is 16. And my c value is 25. Big numbers right there. So 40 squared is going to give us 1,600. Okay. So, no, hold on. No, we're not doing 6. No, we're doing 40 squared. Sorry. And something's going on here. What's going on with... okay, there you go. So 1,600. Now a negative times a positive is a negative, and a negative times a positive. So I know it's going to be negative there. So let's do 4 times 16 times 25. And that's going to be 1,600, which gives us 0. Okay, so since this is 0, according to our chart that we wrote down, then that means that we're going to have 1 rational solution. Okay, this just read it straight from the chart. And that also means that we're going to use the factoring method to solve this.